A golfer hits a ball from a platform that is 15 feet off the ground. Its height in feet above the ground is given by this function, h at t, where t is measured in seconds and h is measured in feet. In part A, we're asked, when will the ball hit the ground? Let's begin with the concept drawing to make sure that we understand the question. So here we have a golfer that is on a platform 15 feet above the ground, and the golfer is going to hit the ball, and the ball follows a path that is quadratic or parabolic. At any point in time, we can determine the height of the ball by plugging that amount of time into the height function. So again, in part A, we're asked when will the ball hit the ground, but what we know about the ball when it's on the ground is that its position or its height off the ground is equal to 0. So in our height function, what we can do is plug in 0 for the height and then solve for t in the following quadratic equation. So we plug 0 in for the height on the left-hand side of the equation, and then we just copy the right-hand side of the equation so that now we end up with a quadratic equation that only has one variable. So in order to solve for t here, let's use the quadratic formula. The value of a is going to be -16. The b value, which is the coefficient on the linear term, is 64, and the c value is 15. As a reminder, the quadratic formula starts off with x is equal to, and then we have the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. In our scenario, we're solving for t, so we're going to start our quadratic formula off with t is equal to instead of x is equal to. Our b value is 64, so we have the opposite of b plus or minus the square root of b squared minus 4 times a times c. Again, b is 64, a is -16, and c is 15. And all of this is written over 2 times a, again, a being -16. And so now our task is to simplify this quantity. We still have -64 plus or minus the square root of. 64 squared is 4,096. And from that, we're going to subtract this negative quantity. And when we subtract a negative, we're basically adding that product. The product of 4 times 16 times 15 is 960, and we're still divided by -32. So we have t is equal to -64 plus or minus the square root of 4096 plus 960 is 5056, and we're still over -32. And from here, let's split this up into the two values that we're coming up with. One of them is t is equal to -64 plus the square root of 5056 over -32, and the other is -64 minus the square root of 5056 all over -32. Let's notice that the square root of 5056 is approximately equal to 71.1. So if we take -64 and add 71.1 to it, we're going to get a positive number in the numerator. Divide that by a -32 or a negative number in the denominator, and this quotient turns out to be a negative quantity. Because we're looking for the amount of time that's passed, a negative quantity is not going to be a meaningful solution for us. So we can just ignore this first value of t. So now focusing on the second value of t, if we take -64 and subtract 71.1 from it, we're going to get a negative quantity in the top. When divided by a -32, that yields a positive time, and that's going to be the one that we're interested in. So this second t value, when we plug all of this into our calculator, yields a time of 4.22 seconds. We were asked to round to 2 decimal places, so we'll go to the nearest hundredth. And that's going to give us the value of time when the ball hits the ground. In part B, we're asked to find the maximum height of the ball. Again, let's begin with our concept drawing. So we have our golfer standing on top of a 15-foot platform, hitting a ball, and we're asked to find the maximum height of the ball. As a reminder, the ball travels a parabolic path that's modeled by this equation here, -16t squared plus 64t plus 15. Now, since the path is parabolic, the maximum height is going to occur at the vertex of the parabola. In order to find the vertex, we determine the value of -b over 2a, and then we'll plug that back into the quadratic function. Because our independent variable is time here, we'll say that the value of time is going to be -b over 2a. So our value of b is 64, so we'll have -64 divided by 2 times a, and our a is -16. So we have negative 64 divided by negative 32, which means that we get the maximum height of the golf ball at time is equal to 2 seconds. So we know that the independent variable quantity is 2, and now we just need to plug that 2 into the height function to determine what that maximum height is. So we calculate the height evaluated at 2. We have negative 16t squared plus 64t plus 15, and we're plugging 2 in for that independent variable spot. So our height function evaluated at 2 seconds is negative 16 times 4. 64 times 2 is 128, and then we're still going to be adding 15. So this is negative 64 plus 128 plus 15, which is 79. So 79 is the output value of the height function when time is equal to 2 seconds, which is also the maximum height of the golf ball, where the maximum height is measured in feet.